The cosmos has always stood as a symbol of the unknown, an infinite canvas stretching far beyond the limits of human understanding. For centuries, we've gazed into the night sky, wondering what lies beyond the stars. Despite the incredible strides made in science and technology, the universe continues to guard its deepest secrets. Many of these mysteries have the potential to revolutionize our understanding of reality, yet they remain hidden, just out of reach. One such enigma has recently come to light, one that challenges the very core of modern cosmology and raises questions about the fate of everything we know. In recent years, the deployment of next-generation astronomical instruments has taken our ability to observe the universe to unprecedented levels. Chief among them is the James Webb Space Telescope. Since its launch and activation, this $10 billion marvel has changed the landscape of astronomy forever, far surpassing the capabilities of its predecessor. The Hubble Space Telescope, Webb, was designed to peer deeper into space and further back in time than ever before, capturing the faintest and most distant signals in the cosmos. Just 2 years into its mission, the telescope has already yielded groundbreaking findings, many of which were never anticipated by the scientific community. In July 2022, Webb began focusing on specific wavelengths of light that are invisible to the human eye. It targeted extremely long wavelengths emitted by faraway galaxies, signals that have been stretched over time due to the expansion of the universe. These signals fall in the category of redshifted ultraviolet radiation. By detecting these ancient beams of light, the telescope can essentially look back billions of years, offering snapshots of the universe in its earliest stages. But while these observations have led to awe-inspiring discoveries, one particular finding has shaken scientists to the core. The James Webb Space Telescope has detected something that seems to defy all logic and established theory: the disappearance of approximately 900 trillion stars. These stars, once part of distant galactic systems, appear to have vanished entirely, leaving behind no visible trace, no supernova remnants, no black holes, nothing. Such a staggering loss of stellar material raises profound questions. Where have these stars gone? How could they disappear without following the processes we understand, without burning out or collapsing in ways we expect from known physics? There are two primary explanations that researchers are currently considering. The first, and perhaps the less unsettling, posits that the stars are still present in some form, but are no longer visible due to a dramatic drop in luminosity. It's possible that interstellar dust clouds have obscured them, or that they have collapsed directly into black holes without undergoing the typical supernova explosions we associate with the end of massive stars. While this theory keeps the stars within the bounds of known physics, it does challenge our understanding of stellar life cycles. The second theory is far more disconcerting. It suggests that we may be witnessing a phenomenon tied to the very nature of the universe itself, a cosmic process of vanishing, one that we are powerless to stop. This idea touches on the fundamentals of cosmological theory and prompts a re-examination of how the universe has changed over time and how it might continue to evolve. To fully grasp the implications, we must revisit the idea that has dominated cosmology for the past century: the expanding universe. In the 1920s, astronomers first discovered that distant galaxies appeared to be moving away from us. This wasn't because they were traveling through space like ships on a sea, but because space itself was expanding, stretching the distances between galaxies. The further away a galaxy was, the faster it appeared to recede. This concept became the foundation for the Big Bang theory. However, this model underwent a dramatic revision just a couple of decades ago. Observations revealed that the rate of expansion is not constant, it's accelerating. Galaxies are not only moving away from us, but doing so at an increasingly faster pace over time. The implications of this are profound, As space expands more rapidly, distant galaxies are effectively racing beyond our reach. When we observe a nearby star whose light has taken 100 years to reach us, we're seeing that star as it appeared 100 years ago, 100 light years away. But when we look at a galaxy whose light has traveled for 100 million years, it's no longer just 100 million light years away. Due to the ongoing expansion of space, that galaxy has moved even farther in the intervening time. On a cosmic scale, this stretching of space plays a major role in how we interpret the structure of the universe. This stretching of space doesn't just affect distance, it changes the very nature of the light we receive. As light from faraway sources travels through the expanding universe, its wavelength is elongated, shifting it toward the red end of the spectrum. This phenomenon, known as redshift, is one of the most important observational clues that confirm the universe's expansion. But redshift doesn't merely validate theory, it provides a tool. By analyzing how light is redshifted across various distances and comparing the apparent sizes and brightness of distant objects to what we know about them, scientists can reconstruct the entire history of cosmic expansion. Moreover, this data gives us insights into what the universe is made of. According to current measurements, about 68% of the universe is composed of dark energy, a mysterious force responsible for the accelerated expansion. Another 27% is dark matter, which does not emit or interact with light, but has mass and exerts gravitational pull. Ordinary matter, everything we can see and touch, makes up just 4.9%. The remaining tiny percentages are made up of neutrinos, antineutrinos, and photons. Despite their minuscule proportions, these numbers are astonishingly precise and critical for our understanding of the cosmos. With this detailed breakdown of the universe's composition, scientists apply Einstein's general theory of relativity to predict its future. The results are sobering. As dark energy continues to dominate, galaxies that are not gravitationally tied to our own will drift further and further away. Eventually, the expansion will reach such extremes that light emitted from those galaxies will never reach us. Not even at the speed of light. The space between us will grow so rapidly that it becomes impossible to bridge the gap. These galaxies, while still existing in physical space, will vanish from our observable universe entirely. Right now, our observable universe spans roughly 46 billion light-years in all directions. Yet, despite this vastness, only about 6% of the total galaxies it contains are still accessible to us. Even if we possessed technology capable of traveling at light speed, we could only reach a small sliver of the cosmos. The remaining 94% is already receding too fast, its light destined never to reach our telescopes again. This number continues to grow, and with each passing moment, more of the universe slips permanently out of reach. Every second, between 20,000 and 60,000 stars transition from being visible and reachable to becoming forever lost beyond our cosmic horizon. The photons they emitted a moment ago will eventually arrive, but the light they emit now will not. It's a haunting realization, one that brings into focus the fleeting nature of cosmic opportunity. If humanity ever hopes to explore beyond the confines of our local galactic group, which includes the Milky Way, the Andromeda Galaxy, and about 60 smaller satellite galaxies, time is not on our side. Each moment that passes is one we cannot reclaim. Among an estimated 2 trillion galaxies in the observable universe, only a rapidly decreasing 6% remain within reach. Unless we develop the capability to travel vast intergalactic distances or find ways to manipulate the expansion of space itself, we will remain confined to our corner of the cosmos. Eventually, communication across galaxies will become impossible. The universe, expanding with relentless force, will silence the cosmic conversation forever. This expansion is not something we can halt or reverse, not with any technology currently imaginable. Gravity, for all its influence, is not strong enough on these scales to pull things back together. The universe will continue to grow colder, darker, and more isolated as time marches on. The stars we once could see will vanish from view, and the cosmic structures that shaped our understanding will fade from the sky. And so we're left not only with scientific puzzles, but also with existential reflections. What does it mean to live in a universe that is slowly slipping beyond our reach? What should we do with the limited cosmic window we have left? The answers are still unfolding. But one thing is certain: the cosmos, in all its beauty and complexity, is urging us to pay attention while we still can.